Hello and welcome to our geometry videos. We are currently in Unit 2, winding down towards the end here. Unit 2, problem number 116. And so we're presented with three problems here where we have to use the relationships in the diagram to create an equation that relates them all together and then ultimately solve for the variable. So, let's see. If it's possible, by the way. If it's not possible, then it's okay. So, let's see. We have three angles in a triangle. We have a representation for all three of those angles. And we know that the three angles in a triangle are always going to add up to 180 degrees. So I can set up the equation, x plus 8 plus 2x plus 3 plus 3x minus 2 equals 180. So we got 1, 2, 3, 4, 5, 6x 8, 19, 11 plus 9 equals 180. Let's subtract 9 from each side. So 6x equals 171. Okay. Let's see what 171 divided by 6 is. It ends up being 28.5. So x equals 28.5 for that one. Okay, so that one was using the idea there's 180 degrees in a triangle, so we took the three angles, add them up, set them equal to 180, and then solve for x. The second one here, okay, let's throw in the monkey here. Okay, we got, oh no, at least like that, okay. So, two angles, need to form a relationship between those angles, so we can set up an equation between those two expressions in order to solve for x. So, these lines are parallel. Parallel lines cut by a transversal give us a lot of angle relationships. I see this 6x minus 28, and I know this corresponding angle down here is also going to be 6x minus 28. And I notice that these two are vertical angles. Vertical angles are congruent. So 6x minus 28 equals 4x plus 18. So I'm going to subtract 4x over here. So 2x minus 28 equals 18. Let's add 28 to both sides. So we get 2x equals 18 plus 28 is 46. Divide both sides by 2, and we get x to equal 23. Okay. So monkey agree. Okay, so x is 23. We used our parallel line properties to determine the relationship between the angles. Once we saw that they were equal, we would then set up the equation that's equal to each other and solve for x. Okay, let's bring in hyena here for the last one. Big hyena, whatever it is. Okay. So a few things here. Let's see what we can do. We have an isosceles triangle. Okay, so if this is an isosceles triangle, I know that these two angles are congruent. Okay, don't necessarily know what they are yet, but we at least know they're congruent. Let's see what we can figure out from this angle of 56. If this angle is 56, then that angle is 56. And the supplement of 56 is 180 minus 56, so that's 124. So this is 124. Okay, so to solve this problem, like, you may not be able to look at something right away and be like, oh yeah, this is the way we do it, or oh, this is the equation. Like, maybe problems like this where you kind of just gotta feel your way out. You gotta maybe use what you're given, fill in all the information that you know, and eventually you'll see a relationship that you can use. So what I'm doing right now is I'm just taking the given information and I'm drawing in all the things that I know, I'm putting in all the additional information to hopefully try and find a relationship that will allow me to solve for x. Okay, let's see, what else do we know here? We have parallel lines, right? This is the parallel line, we can extend that there. So parallel lines cut by a transversal here means that these alternate angles are congruent. Okay, cool. So we have an isosceles triangle. These two angles are congruent. We have this x, which we're trying to solve for, which is unknown there and there. We got vertical angles here, which are 56. We have this angle measure, which is 124. Okay, I'm going to solve this using a system. It may not be the easiest way, maybe there's another way, I don't know if you can see it or not, but I'm going to solve this using a system. I don't know what these are, so I'm going to call them y. Well, I know that x plus y equals 180, because the three angles in a triangle have to equal 180. It's a triangle sum theorem. So x plus y equals 180. I also know that x plus y plus 56 equals 180. So let's write that out. X plus y plus 56 equals 180. So I'm going to simplify the top equation there. So we get x plus 2y equals 180, and the bottom equation is x plus y plus 56 equals 180. And so since both of these equations equal 180, I'm going to set them equal to each other. So x plus 2y equals x plus y plus 56. And a nice thing happens here, right? The x on this side and the x on that side cancel out, right? The sound that it makes. And then I'm going to subtract y from both sides, and we have y equals 56. But unfortunately, that's not what we want. We want x, but it's going to help us out. Because if this is 56, then this is 56, and we know that x is then just 180 minus 56 minus 56. Or in other words, x is 180 minus 112. And 180 minus 112 is 78. I was right the first time. 68. I don't know why I got myself. Oh, you're right. Okay. So, we had to play around a little with the, this is a really good problem, by the way. We had to play around with the relationships there. Good problem, in fact. Okay, we had to play around with the relationships there in order to find a couple of distinct relationships between some knowns and unknowns, and then once we were able to relate those together in two different ways, one using triangle sum, another one using supplements there, we can create two equations. Once we have two equations and two unknowns, it's just like a system, so we can solve that system. Substitution, which is what I did, a linear combination, anti-method there, which allowed us to get one variable, we could plug that back in to get the other variable. So, good problem here. If you have any questions on any of those in this particular segment, feel free to leave a comment. Otherwise, as always, you can like, subscribe, or share to our geometry videos.